Very good day. So here in this particular lecture of Geomagic Design X Go, we are going to continue exploring into the further capabilities of Geomagic DX Go. So here we can go ahead and start by importing our file. So we can start working on day 3, and here we have a file called seatback.stl. So we can import this particular file, and right away you can notice that the file has imported. It's a mesh of a seat. So for modeling objects like these, it's a bit difficult using traditional more block type approaches or more parametric modeling approaches like extrude or revolves or lofts. So DXGo is equipped with the Auto Surface tool. So in the Exact Surfacing tab, we have an option called Auto Surface. So in Auto Surface, the software will automatically create four-sided NURB patches around this particular body. And after it creates those NURB patches, it will ensure that those patches fit to the mesh that's lying underneath. So once you click on Auto Surface, you'll be prompted to this widget, and you have two different types of formulations: mechanical and organic. So here we have two approaches, mechanical and organic. The mechanical approach is more suited for bodies that are machined parts and cast parts. So an improved emphasis will be added in areas on the high curvature, and the organic approach is suited for bodies like this, which is more free-flowing. Examples would include sculptures, figurines that are more natural and varying in shape, and here the software will add the patches in order to capture the shape of the body more accurately. And coming down to the next box, we have a network called the patch network option. So the patch network option, here we have patch count. So either you can let the software estimate the number of patches, which is in auto estimate, or you can choose a target patch count and provide a number. So you can provide something like, let us say, 600 or 800 patches. A patch is a four-sided NURB patch, so it would have four splines as its boundaries, and it will form something similar to a boundary fit surface. We'll see that shortly. So once you have this patch network on, we also have two options for the fitting type. One is adaptive and another is constant. So after the patches are made, we need to choose how many points or how many control points are required for the patch in order to fit the surface to the underlying mesh. Adaptive implies that the software would choose it, and in the case of a constant, it will obtain these fitting options based on the geometry capture accuracy. So we'll go ahead with adaptive, and we can go to the next stage. Now the software is thinking for some time, so it's attempting to make a patch layout. Now this is what you call a patch layout, and each of these four-sided items is called a patch. So here we have one line, spline 2, spline 3, and spline 4, and we have all these points lying here. This is 1, 2, 3, 4, 5, 6, 7, 8 points, and likewise these points would be matched into a grid. And now if we go ahead and say apply, the software will generate the surfaces. So the first part is forming or drawing these four-sided patches, And here, as you can see, it has performed the surfacing and it has rendered a surface. Now this is called an auto surface, and this will always be accurate. So we can say OK here. And now when we check the accuracy, we can see that it is very, very green. You can also uncheck the edges and you can see that it looks pretty much like the scan body. And that's the purpose of the auto surface tool. The auto surface tool is to extract out a CAD surface. So you can go here to the surface bodies and you can export this particular surface as a step IGES or a parasolid file. So I can go here and export this as, let us say, a step file. And I can say seed underscore back. Now you can send this step file to a CAM software and use it for machining applications. You can generate toolpaths from these, etc. So this is the auto surfacing approach, and you can always go ahead and edit this particular body. So you can try different combinations. You can even try giving mechanical. You can add more patches, say like 2000 patches, and you can try and test out on how your output is going to vary. So the more the number of patches, the smaller the size of the patches is going to be, and it will be more accurate in capturing the surface of the mesh. So this is a case like that where all the patches look pretty regular in shape, they are all uniform, and they're very small. So a model like this would be very, very, like, extremely accurate when compared to the cases where the size of the patch is slightly larger. And we'll give it a moment to finish since the number of patches are so small. And here is the output of our surface. And if we show the edges, you can see that it's a nice smooth flowing output. This is how you can automatically import a particular body and convert it into a surface, which you can open up in any of the CAD files.